Okay, now let's look at some that may have different solutions. So some special cases are that we could have one solution like we've already seen. We can also have no solution or infinitely many solutions. So let's solve a few problems and see how we recognize when they have special cases. First on this problem, we need to distribute 3. So 3 times 5x is 15x, and 3 times 2 is 6. Now we check to see if we have any like terms we need to combine, and we do not. So now it's time to move the x's all onto one side. This 15x is by itself, so I want to move this x over towards the right side of the equal sign. So what I'm going to do is I'm going to subtract 15x. That way it moves over to the right. So that leaves me with 6 equals 15x minus 15x is 0. So all my variables seem to have disappeared. What happens is they all simplified out, and I'm left with 6 equals 0. So I know that this is either going to be no solution or infinitely many solutions. So how you can tell is 6 equals 0 is not a true statement. 6 does not equal 0. So that is an example of a problem that would have no solution. So when you see something like 6 equals 0, or 5 equals 8, or -1 equals +1, those are untrue statements, so when you get that and all the variables have simplified out, you know to write no solution. Let's go ahead and try another one. First, on this problem, we need to distribute because we have a set of parentheses. So I'm going to distribute the -2. I have -2 times 4y is -8y, and -2 times 1 is -2. Now, from here, I still have the right side by itself. There are no like terms to combine, so I'm ready to move my variables all to the same side. So what I'm going to do is I'm going to go ahead and add 8y to both sides. What happens now is that -8y plus 8y is 0, so I'm left with just -2. -8y plus 8y is 0, and I'm left with -2. So now this is another case where all the variables simplified out. -2 does equal -2. So that means this is infinitely many solutions. This is also considered what's called an identity. So if an equation is an identity, then it is infinitely many solutions. And how you recognize it is when all the variables simplify out and you get something like 3 equals 3 or -2 equals -2, something that's clearly true. So I'm going to give, for example, 14 equals 14. Or 3 equals 3, or -2 equals -2. When you come up with a solution like that, that's true, but there's no variable, then that is infinitely many solutions. And it's also known as an identity, and that's when an equation is true for all numbers you can put in. All right, I'm going to go ahead and have you try C on your own. Give it a shot and see if it has a solution like normal. How you know when it will have just one solution is it'll just end up with like x equals 5 or p equals -12. You'll just get an answer like normal. So let's find out if C has one solution, no solution, or infinitely many solutions. All right, so you should have distributed the 4 first and get 4 minus 4p equals -4p plus 4. So now I don't need to do any combining like terms in this case, but I do need to move the variables to where they're on the same side. So I'm going to add the 4p. So right here, -4p plus 4p is 0. Same thing here. So I end up with 4 equals 4. So hopefully you found out that this was true, therefore it is infinitely many solutions.